Dear learners, welcome to the Swayam MOOC course on Geography of Health and Well-being. Today, we will continue our discussion about climate change and its impact on human health. After the completion of this module, you will be able to understand the role of climate change in equity, justice and sustainability, to be able to understand the urban heat islands and examine the health impacts of these urban heat islands. It will also help to develop awareness and responsibility towards climate change. The severity of health risks will depend upon ability of public health and safety system to address or prepare for these changing threats, as well as factors such as individuals' behavior, age, gender and economic status. Impacts vary based on where a person lives, how sensitive they are to health threats, how much they are exposed to climate change impacts, and how well they and their community are able to adapt to these changes. The impacts of climate change are not evenly distributed and thus raising issues of social justice. Some groups of people are more vulnerable than others. Three factors that contribute to the vulnerability are sensitivity, which refers to the degree to which people or groups are affected by a stressor such as high temperatures. Second, exposure, which refers to physical contact between a person and the stressor. And thirdly, adaptive capacity, which is the ability to adjust to or avoid potential hazard. For example, while older adults are sensitive to extreme heat, an older person living in an air-conditioned apartment won't be exposed as long as he or she stays indoor and as long as they can afford to pay the electricity bill to run the air conditioner. Their ability to take these actions is a measure of his or her adaptive capacity. On the contrary, a street hawker may not have contributed as much to the greenhouse gases, but may be more vulnerable to extreme heat due to higher exposure and low adaptive capacity. As we have seen, climate change affects almost every aspect of our lives. Although climate change affects all the humankind, however, the people most severely affected by climate change are ones who are historically least responsible for it. And this is the fundamental injustice that lies at the very heart of climate justice debate. Justice in its most fundamental understanding refers to fairness and equity. Environmental justice approach insists that climate negotiation should include the community participation in the decision making and implementation process. That is, climate action should follow a bottom up approach. Environmental degradation does not take place in isolation or does not follow any political boundary. Therefore, the impact of climate change is not limited to any one region or country, rather have the potential to affect global atmosphere, global community. Hence, any attempt to mitigate the impact of climate change should take into consideration the dimensions like intergenerational equity, rights of indigenous community and the north-south relations. From global climate, We now come to microclimatic changes. That is formation of urban heat islands. This is a phenomena where the temperature of urban center is recorded about 2.5 to 6 degrees Celsius higher than the surrounding rural hinterland. The factors contributing to urban heat islands are concentration of human activities, high density of concrete buildings and surfaces that have high absorption and low reflection, that leads to creation of an island of heat surrounded by a sea of cooler rural areas. The first documentation of urban heat island was done in 1833 by Luke Howard's groundbreaking study of London's climate using meteorological data. Later, satellite data was used by Rao in 1972. That was the first to use satellite data to examine spatial thermal pattern and its impacts. It has been noted that urban heat islands are much severe in summers, especially in cities of tropical climatic zones. Urban heat islands can be classified broadly into two types: atmospheric urban heat islands and surface urban heat islands, or SUHI. The surface urban heat islands tries to understand urban heat island formation with the help of surface temperature acquired from satellite images, while atmospheric urban heat islands depend upon atmospheric temperature data analysis collected from fixed or mobile weather stations. The factors affecting urban heat islands intensity are geographic location, that is whether the place is located in interior continent or near the sea. Climate, what kind of climate it has, very hot, cold, moderate, is it a coastal place, is it located near the foothills of the mountains, so the climate would be moderate. Topography, time refers to season, how many seasons that place experiences, 2, 4, 1. What is the duration of day, that is duration of sunlight. City size, is it a small town or a city, metropolitan or a megalopolis. Wind direction, status of cloud cover. City geometry, that how the buildings are arranged in a city, how much street space is there for wind to pass on. Green spaces, city morphology and material used, energy use, pollution levels and rural surroundings. Balanced heat budget is critical for maintaining the temperatures of any area. In urban areas, the incoming solar radiations and outgoing long wave radiations are trapped between the buildings, thereby increasing the temperature. The closely spaced high-rise buildings restrict the wind movement that can act as a moderator otherwise. Plus, the material used for construction, that is asphalt, glass, metal, concrete, have higher albedo, meaning they tend to absorb the sun's radiation or insolation and easily become warmer. Additionally, there is massive land use, land cover change due to urbanization that has replaced the natural vegetation areas, forests and water bodies into concrete impermeable zones, further accentuating the temperatures and altering the water cycle. Due to high intensity heat and nature of development, anthropogenic heat released from air conditioners, vehicles, industries further intensifies the urban heat island. Apart from land use, land cover changes, the spacing of buildings, urban geometry influences wind velocity, movement, direction and energy heat balance that also influences UHI intensity. As a result of these factors, the cities tend to experience elevated temperatures as compared to surrounding rural areas. Many researches have proven that city size determines the intensity of urban heat island. That means larger city will have stronger UHI effect as compared to a small city. We can see the video presented in the link below to understand the concept of urban heat islands better. Unplanned and unregulated and haphazard urban growth and associated microclimatic changes imposes challenges for human health. As a result, urban areas are the prime centers or hotspots of development, are experiencing rise in the burden of diseases. Often, urban areas are considered as centers of paramount health facilities, best health facilities, but the population growth and their needs modify the physical environment to the extent that it exerts negative impacts. The atmospheric composition of gases has been altered by industrial and vehicular growth and changes in consumption pattern and lifestyle of human beings. There is rise in concentration of oxides of nitrogen, sulfur and carbon. Added to this is the SPM, suspended particulate matter, and trace elements such as benzene, ozone that are increasing. Due to trapping of heat energy by greenhouse gases and other related causes, the microclimatic condition change in urban areas. The combined effect of these two environmental changes is the increase in temperature that has far-reaching and long-lasting consequences on human as well as environmental health. The diagram given below presents the types of health impacts of urban heat islands. Urban air pollution causes range of health effects ranging from eye irritation, skin infections, spread and rise of infectious diseases, asthma and allergic disorders, COPD, that is chronic respiratory disorders, chronic heart disorders, chronic heart and lung diseases, asthma, cancer, minor eye or nose irritations, allergy and even death in some cases. Following is the heat related pyramid that we can see on the screen. Depending upon the duration of exposure and individual vulnerability, the impact may be less severe, such as heat fatigue or skin infection, to heat cramps and stroke that will need medical admission or even death. It is very difficult to generate data for temperature and humidity, but with the advancement of remote sensing and GIS, we have been able to harness the data collection through satellites. The land surface temperature can be extracted from satellite images. There are 6 major sensor systems that provide thermal data and mostly used by scientists for estimation of urban microclimate, land surface temperature and urban heat island. These are Landsat, ASTER, MODIS and sun synchronous systems, while AVHRR is a polar orbiting sensor. The Landsat and AVHRR are the oldest and largest thermal data sensors that have been providing data since early 1980s. Aster and MODIS, on the other hand, have been recently launched in 1999 but have proved to be very effective for land surface temperature studies in urban areas. Many communities are taking action to reduce urban heat islands using the following strategies. 1. Increasing tree and vegetation cover. 2. Installing green roofs. Installing cool, mainly reflective roofs. Using cool pavements which are reflective and permeable. Utilizing smart growth practices. Now we also have projects of sustainable cities, smart cities and green cities all across the world. It is important to use these materials and the knowledge that we have gained today to have better planning so that water retention areas, porous areas, vegetation and water zones are not changed into built up or impermeable landscapes. This will help in keeping the temperatures low. Also, vertical gardens, terrace gardening are some of the good options. The white color of the buildings tend to have higher albedo. Plus, planting trees across the streets will help in providing shade as well as maintaining temperature. One can incorporate the use of cool materials for streets and pavement covers. Ensure enough green spaces in the city scale such as parks and open fields. Maintain urban water bodies such as rivers and lakes within the city and harness natural wind to effectively mitigate urban heat island effects on human health. With this, we covered the module on climate change and human health. For more information, you may refer to the following books, articles and websites. Thank you for your patient listening. Thank you.